volume inspection using IBM-CELL. It's a PlayStation. I am not going to play any games with this PlayStation 3. A most affordable one of IBM-CELL is available with PlayStation 3. This IBM-CELL is jointly developed by Toshiba, IBM and Sony. IBM-CELL consists of a single PPU and 8 SPUs. Out of 8 SPUs, 6 SPUs are enabled for the developers, and a PPU which OS and normal serial programming, normal C code will be running. And these out of 6 SPUs, all the 6 SPUs are of SMID cores which can do the parallel operation, and each SPU is having its own local memory which is 256 KB and a main memory which is 256 MB. But by using DMA we are going to access the local memory, and each SPU is having its own local memory. All the SPU cores are SMID cores which can do the parallel operations. If you want to programming in SPU cores, we have to use SDK, which is the software development kit which is provided by the IBM. By using the SDK, we can work with the SPUs which will do the parallel operations to our application. Inside this Sony PlayStation, we have the IBM-CELL. In this IBM-CELL, we have installed the LODOG Linux and LODOG Linux. This LODOG Linux will be running in the PPU, what I told, power processing unit. Inside the PPU, our OS as well as the normal C code will be running. If you want to go for the parallel programming, then we have to go for the SPU. SPU are capable of doing the parallel programming that are of SMID cores. MPR means reconstructing a section of volume in any desired direction as a 2D frame is MPR. In this MPR, we have developed the 3 views: axial view, sagittal view and coronal view. Axial view is the front view of the body, and sagittal view is the side view of the body, and coronal view is the top view of the body. You can see it's a volume. Typically it's a 3D data grouped of 2D slices acquired from the CT or MRI scanner. Usually they will be in a regular pattern, like each slices will have a gap. It depends upon the CT or MRI scanner. Why we are getting output in such a way from MRI scanner means the body has to expose and it will take too much time. Here these are 3 screenshots which have taken from our MPR application which is developed in our IBM-CELL. And why we went for IBM-CELL means, suppose we have 2 slices. If your user wants a slice between these 2 slices, but by using the information of these 2 slices, we are going to produce a virtual slices by doing the interpolation. If you are doing the interpolation, we have used the trilinear interpolation. If you want to interpolate the 0th pixel, we have to find the 8 neighboring points, which is a highly competitive task. Because of that, we have used the IBM-CELL. This IBM-CELL is capable of doing the parallel operation. This is the axial view, front view of the body. This is the volume. From the volume, we are going to see the front view. You can see now we are going the inner to the volume. You can see the difference between the each slices. We are going one by one slice. You can see now we are going inner. You can see the difference between the slices. We are going inner. Now we are here. You can see we are going inner to the volume. If you want, you can come for the back. This is the front view. We can see the side view of the body. Now we are going inside to the volume. If you want to come for the back, this is the sagittal view, which is the side view of the body. The entire thing, you can see these are snaps of what we have taken from our existing application. This is the axial view, which is the front view of the body, and this is the sagittal view, which is the left side view of the body, and this is the coronal view, which is the top view of the body. You can see in the coronal view we can see the entire thing. Now we'll see our coronal view. Black side, because here all the things are black. Initially we'll have the black. Now it's going interior to the volume. You can see this is the front view. We can see entire body of the slice. Now it's keep on going inside to the volume. Okay, it's a Ampere what we have implemented in the IBM-CELL in order to improve the performance in normal CPU. What I told here, we are doing the interpolation in order to generate a virtual slice. If we are doing in normal CPU, we had to get each pixels, but by using IBM-CELL, at a time we can have the chunk of pixels, because this IBM-CELL is having 6 SPUs, which is of SMAD cores, which can capable of doing parallel operation.